Hi everyone, my name is Andrew Banson. I'm an application specialist at Civil Survey Solutions. In this tutorial, I wanted to demonstrate some of the new functionality in Civil Site Design version 17.01 by running through this intersection reconstruction. This data set is a variation on one of our standard data sets that install with the software. I will make this data set available on our blog, so if you do want to run through it later on with this new update, you'll be able to. In this project, we are aiming to upgrade the existing intersection with a roundabout and some islands to better manage the movement of traffic through this intersection. Before I start, I will run through the civil data that I have already created. Firstly, we have a civil 3D surface named NS. This is my detailed survey, and I also have some alignments that represent the centre line of the road. These are alignments that I've added to this data set, one called main road and the other one called side road. When I create these rows, I'll probably create them with a 50mm overlay over the existing. I also have some alignments for the roundabout and the island. The islands, these will be draped onto the design surface using the drape string command. I also have an alignment to control the width of the left curb, and I have another alignment which is in the location of the existing curb. And I am going to set up an infill between the new curb and the existing curb. Just jumping into the template editor, this is the template that I'm going to apply to both the main road and the side road. Very basic template with some curb and channel either side. I have added a code in called LKEB, and this is going to be my connection code back to the existing curb, or existing top of curb, to form an infill region. If I have a very quick look at the sub base, I've got a layer of asphalt and I've got another layer of crushed rock. That layer has actually been set to match its depth to the surface, so it's sort of my resheet layer. And I suppose later on I could come in and put a saw cut region here and specify full depth pavement out from the curb. And I might get to that a little bit later on. Okay, so I'm going to jump in and start designing this intersection. I might do this tutorial over a number of videos. I'll just see how long I go on each one. So the first thing I'm going to do is run create road and create my main road and apply that template I just showed before. And I'm just going to create the side road as well. Apply that template. Now, in regards to the side road, you can see that auto ease, auto transition has been added. And if I was to go and delete that IP, you can see it just keeps coming back there. And that means that if I was to do my overlay, I won't be able to through that region because of the auto transition. So what I'm going to do is open up resample sections for the side road, jump into auto VCEs, and I'm just going to turn it off by setting it to never. This won't turn it off, but it'll mean, well, straight away, but it'll mean that if I open up the vertical grading editor, I'll now be able to delete that IP. Actually, one of our most common tech support requests we get is that IP that gets added at intersections. Okay, so the next thing I'm going to do is I'm going to open up the vertical grading for the main road, and just to get started, I'm going to run a match to existing and tell the software to put in a 50mm overlay. I could use the resheet command, which would do something similar. That would allow me to nominate the left and the right side alignments and specify a minimum overlay, and the software will raise and lower the center line to achieve that. but in this case I'll just go and tell the software for the whole length, reference the natural surface, within some tolerances in cut and fill, raise the design at the center 50mm and apply that. And that just gives me a good sort of starting point. You can see we're not always at 50mm, and if I wanted to be closer to 50mm, I would go in and tweak the cut and fill factors. But for this example, that's good enough. It's a good starting point. I'm just going to jump into the side road and do the same thing. Match to existing for the whole length. Set up our design so that we are about 50mm above the existing. Okay. Right, so that's the roads created. Next thing I'm going to do is just add the curb return. So I'm going to run the curb return command. Add a curb return here. I'll try 10 meters. That looks pretty good. And then I'm going to add a curb return in this area. It looks to be about 30, maybe 40. There we go. Okay, so curb returns added. Next thing I want to work on is this region through here. So I'm just going to tell it, it's pretty close. That's my alignment for the new curb width, but what I'm going to do is tell the software that my left edge of bitumen is going to match its width to that alignment running all the way around through there. In fact, that alignment called curb extends pretty much all the way up to the top here. So I can apply that by using a simple variation. If I open up the design data form for my road, I'm going to add a variation, a very common one, set code offset to alignment. And I'm going to say grab the left edge bitumen code for the entire length, change offset and level, which means it just projects that minus 3% out until it reaches curb. So when I click on add update, you'll see that line work will offset to my alignment, which it has done. So let's just open up a cross section, and I'll open one up sort of through this region here. And if you have a look at the cross section, you can see that blue line indicates my existing curb, and you can see the curb shape here. What I'm going to do next is tell the software to grab that LKEB code that I created. That's this one here, LKEB, and I want to match to the alignment to the surface, so it should match pretty well on top of that existing curb there. This is another very useful variation when doing road reconstruction. So add variation, and this one is called set code levels to match surface, and I'm going to say grab that LKEB code for the whole length, match to the existing, and match to the existing top of curb, and that alignment was called curb L match. I could put an additional height adjustment in if I wanted to. Optional inside code is useful for bringing internal codes up to the same location or reference off the same location that you're matching the main code. I won't do that in this example. So if I click on add update, you can see we've now pushed out LKEB to that existing location. Now, just reviewing the subbase very quickly, I'd already pre-set up a match to existing with a minimum thickness. So you can see here the software's matching the surface, but to achieve the minimum thickness, you can see that we're cutting into the existing through there. I might just show you how I've done that by setting up a infill for this region here. So all I do is open up my template, and I'm going to edit subgrade between, I'm going to have to go set subgrade, and I'm going to say that between the backer curb and LKEB I have a new subbase region, and I'm just going to put in a nominal thickness of 30 mil of infill, but I'm going to tell the software that this infill will match the existing surface. So to do that, I click on Assign Layer Controls, Match Depth of Surface, yes. I can put a minimum and a maximum, minimum thickness and a maximum depth. So if I click on Apply Exit to that, Apply Exit and click OK, you can see there now we've got that infill region, and that means that I could output some materials for that, material totals for that region there. Okay. So we've pretty well got this an initial base surface set up, which is controlled using auto model. So if I click on auto model, I'll just turn on some contours, and we can see our base surface created there. To create the drape strings, really easy for the island and the roundabout. Remember, these are the strings that are going to match onto that total model surface. To do that, I run the create drape strings command. Now I've actually already sort of preset this up just to save some time, but all I've done is told the software that the islands, the roundabout, will be matched to total model. We're applying a very basic metric curve left template with some very tight spacing so it models well, and update mode is set to auto. So if I click on update all, software will create all of those drape strings for me. And if I was to open up the vertical grading editor for one of those, you can just see that they're just draped over total model. If total model changes, then you simply run the update draped strings command, and all those drape strings you have in the design will be rematched onto the surface that they're referencing. So I'm going to model up this probably in the next video, so I'll try and keep these down to under 15 minutes. But what I'm going to do is open up Model Builder, and I'm going to run create new model and create a new model for each of these islands and the roundabouts. I'm just going to select on create new model. This is for island 1, the first one, and island 1 will just include island 1. So I can hit build and save. Alright, so then I'm going to do the same thing for island 2, include island 2 and build. So I like using Model Builder to build those individual elements for a number of reasons. I mean, I could open up the vertical grading editor for one of them and run this command. It would build a surface for me. However, for the islands and the roundabouts, you'll find it puts a height boundary in the middle, so that's one reason why I don't like it. But the Model Builder gives me more flexibility if at any time I want to trim or clean those elements up and add extra features to them, extra brake lines or whatever. Model Builder gives me that flexibility. That's why I like using that method. So I'm going to end this first part 1 now, but when in the next part I'm going to go into Model Viewer, start visualizing up this intersection and showing you a few new tools that we've added to the software.